In this talk, we will learn about different abiotic factors that can affect the climate of Earth. There are global abiotic factors that affect living systems on Earth. This includes the amount of solar radiation that a region receives and any variations that are associated with that radiation. The global atmospheric circulation, which includes winds and ocean currents, can also change from place to place, affecting those ecosystems. These factors together can affect the climate of a region, which is the long-term weather conditions of any given region. In summary, the climate of a region thus depends on temperature, sunlight, rainfall or precipitation, as well as wind. Solar radiation has a huge impact on climate. The Earth receives most of its energy from the sun. This solar radiant energy passes through the Earth's atmosphere in the form of light waves. The intensity and wavelength of these light waves can change as it passes through the atmosphere and hence affects how much of energy is actually present on Earth. It is estimated that of all the energy that comes into the atmosphere, half of it is absorbed within the atmosphere, while the other half reaches the Earth's surface. The gases present in the atmosphere are able to absorb certain wavelengths of solar radiation, and they allow other types of wavelengths to freely pass through and reach the Earth's surface. It is also found that some part of the Earth's surface tends to receive more energy from the sun than other parts. For example, the central part of the Earth tends to receive more solar energy than the higher latitudes. It has been found that the intensity of sunlight is the strongest in the tropical region. This corresponds to the region between the Tropic of Cancer and the Tropic of Capricorn. This is because the sunlight strikes the Earth most directly in this region. The angle of incidence of the light can also influence the temperature of a region. The angle of incidence is the angle at which sunlight hits the Earth, and it can affect the intensity of sunlight as well as the amount of heat and light per unit surface area. This is why there are higher temperatures in the tropics, and when we move away from the tropics, the temperature starts falling down. We all know that the Earth orbits the Sun and rotates on its own axis. This orbiting around the Sun, as well as rotation on its own axis, affects the long-term weather conditions of different regions, which corresponds to the climate. The daily rotation on its axis creates night and day. However, the revolution around the Sun on its axis determines how long the night and day will be. In certain parts of the year, we have equal night and day, while in other parts of the year, we may have longer nights, and yet other parts we can have longer days. The revolution around the Sun also creates seasons. In many areas, we have hot summers, wet monsoons, cooler autumns, and quite cold winters. The progression of seasons occurs in all parts of the Earth. For example, in North America, the seasons always go in the sequence of spring to summer to autumn to winter and then back to spring. This is all due to the revolution of Earth around the Sun. Solar radiation can affect global air circulation patterns. It is known that hot air rises upwards as compared to cold air. There is more solar radiation in the tropics, which includes the equator, which causes the air to rise from the surface to higher parts of the atmosphere. This rising air is rich in water vapor. This is because warm air tends to hold more moisture than cold air. The solar radiation at the equator also facilitates the evaporation of the water to provide the water vapor or moisture in the air. As the warm, moist air moves from the surface of the Earth at the equator to higher altitudes, it cools down and the water vapor condenses to provide rain in these tropical regions. The air now is dry and it can descend back at around 30 degrees altitude in the north as well as southern hemispheres. Since the air does not have much moisture on the surface of the earth, these regions tend to be dry and create arid zones, which we also call as deserts. Around 60-degree latitude and the north as well as southern hemispheres, we once again observe moist air rising upwards and then cooling down to provide rain in those regions. However, the amount of moisture in the air is less than the tropics, and hence the rainfall is also less than what is observed in the tropics. The airflow that happens in different regions on Earth creates predictable wind patterns. The movement of air as well as the rotation of Earth can tend to create wind patterns that curve towards east or west. This is called as the Coriolis effect. In the tropics, we can observe the northeast trades and the southeast trades that tend to blow east to west, while in temperate zones, we observe the westerlies that tend to blow from west to east. In addition to the sun and winds, ocean currents also influence the climate of terrestrial environments that are nearby. They're able to do so by heating or cooling the passing air. It should be remembered that water is a bad conductor of heat and hence has a high heat capacity. It takes time for it to heat up or cool down, and this can affect the surrounding air appropriately. Ocean currents are influenced by global wind patterns, including the Coriolis effect that causes winds to curve east or westwards. This curving of the winds affects the direction of ocean currents as well. The oceans and the air above can affect the formation of hurricanes or cyclones that bring a lot of precipitation and strong winds to coastal regions. Mountains can also influence the airflow over land and affect climate in the surrounding areas. Many mountain ranges across the world can actually be found near water bodies like seas and oceans. The side of the mountain that faces the water body is the windward side. The wind that blows from the water body towards the mountain is usually warm and moist. It is moist because it obtains water vapor from the oceans or the seas that it blows over. As this wind rises above the mountain, it cools down and releases moisture in the form of rain. Thus, the windward side has more water content in its soil, and correspondingly, the windward side has more vegetation. The dry air that has cooled down due to the elevation descends down the mountain on the opposite side that is called as the leeward side or the rain shadow. The rain shadow is a patch of land that looks similar to a desert. This is not only due to the lack of rainfall, but as the air descends, it absorbs moisture from the land, creating drier conditions on the leeward side. Elevation, which is the change in altitude, can affect the climate of the surrounding regions. Temperature and other conditions change with elevation. It is estimated that the air temperature falls approximately 6 degrees Celsius for every 1,000 meters increase in elevation. Air is also less dense at higher elevations. In fact, at higher altitudes, the climates tend to be similar to what is observed at higher latitudes. At the lower altitudes, we see a lot of vegetation similar to what is observed in the tropics. As the altitude increases, the vegetation looks more similar to what is observed in the temperate regions. As we go further up, the vegetation becomes more sparse, and we see organisms that are normally found in the taiga region. As we go even higher in elevation, the temperatures become a lot colder, and the vegetation resembles what is observed in the tundra regions. The tundra regions are those that are closer to the poles. Finally, at very high altitudes, we observe icy regions that are similar to the poles. The monsoon are seasonally shifting winds that provide rain. They're normally observed in Asia, and the duration and strength of the monsoon determines how much food is available each year to hundreds of millions of people that live in that region. Asia is a huge continent, and the heating and cooling of its surface causes massive regional shifts in winds. In the summer, the winds blow from the water towards the landmass. As they do so, the winds gather moisture from the water bodies and then release this moisture as they pass through the land in the form of rainfall. In the winter, the winds blow the opposite way, from the land onto the water. Thus, the monsoon can influence rainfall patterns in regions in Asia. While there are many different factors that affect the climate tends to be very predictable. Predictability of climate encourages biodiversity. It allows organisms to evolve accordingly. However, when the climate becomes unpredictable, it can be overall detrimental to living organisms. It can prevent the optimal production of fruits and vegetables. It can also prevent the appropriate storage of food by organisms, thereby causing them to starve. It can also change reproductive patterns. Hence, it is really important for climate to be more predictable. However, we should remember that Earth's climate has indeed changed over time. We have gone through cyclic periods of cooling and warming over millions of years. In fact, land masses have also changed over time. In early Earth in the Permian period, we can see that all the land masses were together in the form of a supercontinent called as Pangaea. As time passed, this continent split to form Laurasia and Gondwana land. As further time passed, the land masses started drifting apart, and as they kept drifting, the locations of these land masses started changing. And today, we are able to see the land masses the way they are. Thus, land masses also change over time, and the climate of those regions will also change. This change, however, is normally very slow, and it allows the organisms to adapt. Now, when there are rapid changes in climate, it usually drives the extinction of many different species. This is because these organisms simply do not have time to evolve and adapt to this changing environment. We have observed this while studying past mass extinctions. Nowadays, we are also observing rapid changes in climate, but it is due to human actions. These rapid changes in climate can cause stronger and more frequent hurricanes, extended forest fire seasons, more flooding, and other types of phenomenon that are detrimental to many different ecosystems. This rapid change in climate is driving the sixth mass extinction. Hence, there is an urgent need to adopt environmentally friendly policies that will help slow down this climate change. With this, we come to the end of our talk where we learned about different abiotic factors that can influence the climate on Earth. We learned about the effects of sunlight, air circulation, winds, and ocean currents on the climate of different regions. We also learned about how changes in climate can be detrimental when they are very rapid.